class, we got you. Wherever you want it from, we got what you need. Don't get online class.
Good day, viewers all over the world. You are welcome to Choide online class. So today we want to look at the third theorem under circle geometry. And the theorem says that angles on the same segment of a circle are equal. This is what we are trying to say. This center of a circle, let's say the center of a circle, so let me call this place AB, and this is the center. So if you have an angle here, back to this point, and probably there's another one back to this point. So let's call it PQ. This angle here, let's say this one is x1, and this other angle is x2. From this theorem, we were made to understand that angle APB is equal to angle AQB. That is, this angle P, S1 starts from here, back to this point. This one also starts from here, back to this point. They are subtended by the same arc. So, and they are subtended by the same arc. You know, when you sketch this chord, you realize that they are from the same point, starting point and the ending point are the same. So the theorem says that angle on the same segment, you know, they are in the same segment. This is the minor segment and this is the major. So these two angles, x1 and x2, falls under the major segment of this diagram. So angle on the same segment of a circle are equal. So angle x1 and x2, they are on the same segment. So we say x1 is equal to x2, and that's how to view it. Angle on the same segment of a circle are equal. So we go ahead and take examples on this, on how to apply this theorem. Angle on the same segments are equal. So let's take note that as from today, we should know that angle on the same segment of a circle are equal. Example? Let's say example 1. So the question says, find the lettered angles in the figure below. That is, we have something like this. So here is A, here is 40 degrees, and this place is B. So how do we get the value of A and B? Solution. So if you look at this diagram very well, angle A starts from here to this point. This angle 40 starts from here to this point. The angle B starts from here to this point. All these three angles are on the same segment. If I decide to just join these two, it forms a, this is a chord. So all these three angles, they are on the major segment of this circle, and they are subtended by the same arc. So we can generalize and use the theorem and say that angle A is equal to angle B and is equal to 40 degrees. Reason, angles on the same segment, they are equal. As I've said in the last class, you cannot make any statement under circle geometry without reason. You should be able to give us convincing reason. A and B, they are on the same segment. Just say A is equal to B. A is equal to 40 degrees. Angle of the same segment. B is also equal to 40 degrees. They are on the same segment, because if you trace this out, you realize that we've divided the circle into two: major segment and minor segment. So if they are on the same segment, the theorem says that they are equal. Let's take another example. Take another example. Let's take another example. We've considered about 3 theorems now. So let me take this example. Find where we are going to apply other theorems there. Find the lettered angles. Find the lettered angles in the figure below. This is it. This diagram is small. Here is the center. Here is the center of the circle. And this place is, let's call this place X. And we'll call this place Y. So, and this place is 135 degrees. It's 135 degrees. So we want to find X and Y. So let's say this, let me change this to 136 degrees. Okay. So we want to find the lettered angles in this figure. Look at, of course, we know that X and Y will be equal. How do I know? If I make the sketch to sketch out a chord here, I realize that angle X and Y, they are on the same segment. So angle on the same segment are equal, X equal to Y. But I don't know either of the two. But I know the center of this circle to be equal to 136 degrees. Then if I know the center, I can find any of this circumference, the angle at the circumference. So I'll just say, I can do name ceremony. Let's say A, B, C, then D. I'll just say angle AOD, which is the angle at the center, is equal to angle A, is equal to 2 angle ABD. Angle at the center is equal to 2 times angle at the circumference. So that's the second theorem. So angle AOD is 136 degrees. Is equal to 2 multiplied by X. We know the reason. Divide both sides by 2. This cancels this. So X is equal to, here is 68 degrees. So X is equal to 68 degrees in this question now. Then once I know the value of X, that X is 68 degrees, I can go ahead and find Y. So I'll just say angle ABC, no, ABD is equal to angle ACD. Angles on the same segment. So angle ABD, that is X. I'll just say S is equal to Y. So we have been able to find the value of X and Y with the knowledge of theorem 2 and theorem 3. So all this theorem, we can actually use all this theorem together. We can apply about 4 or 5 theorems in a particular question. It's our ability to be able to recognize the problem and be able to think fast on how to approach that problem. So in conclusion, we should know that theorem 3 is just talking about angles of the same segment being equal. And of course, I've shown us how to locate the segments. Once we're able to sketch out a chord, and you realize that their starting point and their ending point is the same, then you can go ahead and generalize. So I'd love to stop here because of our time. We'll continue from there some other time. Thank you.